All right, GAC, this is Coach Johnson. Hope you're having a great day today. This right now is the Wednesday before our Thursday test. And again, hope all is well. Hope you're studying hard and hopefully you're starting to get the material here. Couple things to note on haiku, on chapter 2, okay, on chapter 2, towards the top, and I'll kind of get this here. I'm trying to see, is this even helping me out here? I think I'll have to keep it on this side. I don't know what happened there, but we'll keep it here. On chapter 2, I'm going to post a couple of podcasts. You've already seen them so far, and you can kind of go on there. But I'm also going to post a couple of Miss Allen's podcasts that you can go on there. Again, that's chapter 2. You can go on there, chapter 2, and you can access that at any time. And basically what that does is that will go over more of these problems than I'm even going through right now, okay? But in order to kind of access or to kind of do this, what I'd like to do is just kind of slowly go through some of these problems and make sure that we are G to G on them, all right? The first one I want to do is number 3. Now with number 3, what we're trying to do is we're trying to get the I out of the bottom. We don't like imaginary numbers in the bottom because just like with square roots, it's not in the form that we would prefer. So as mathematicians, we like to get rid of that. So what we'd like to do is to multiply by the opposite sign, or what we call the conjugate of the bottom. Now, when we do that, what happens is we can now distribute 15 towards the top. And when we do that, what we end up getting is 45 minus 5 times 15 is 75i. So we get 45 minus 75i. And down below, we're going to distribute. So 3 times 3 gives me 9. 3 times negative 5i is negative 15i. 5i times 3 would be 15i. And 5i times negative 5i would be negative 25i squared. Okay? Now, negative 25i squared would be the same as saying negative 25 times negative 1. Okay? Right in there. All right? So, once I get to that, what I can do is kind of get to the point where now we simplify. So the 15s cancel, leaving me with 9 plus 25. So 9 plus 25 gets me, and I'm only able to work in this space, so I'm sorry about that. But the idea is at the top, you would end up getting 45 minus 75i all over 9 plus 25, which is, on the bottom, 34. So if I were to really simplify this and really take this a little further, I would say 45 over 34, which I don't think we can simplify any further, minus 75i over 34. And that right there would end up being what my answer would be from that, all right? Again, hopefully that helps you out there, but that's kind of the idea of what we want to do with that I and getting rid of that I from on the bottom, okay? All right. I'm going to do this. I'm going to try to see if this will work here. Trying to see if this one will work because right now it's kind of messing up. I don't know what's up with the bamboo tablet here, but we'll keep going. We'll keep rocking. We'll persevere through, okay? We'll keep it in this spot. All right, the next one is 3 plus 8i multiplied by negative 2 minus 5i. So again, that's this one over here, number 8. Or number 4, I'm sorry. So in this one, just like we did before, we're going to distribute 3 times negative 2 and 3 times negative 5i. Make sure you distribute. So we would get negative 6 minus 15i. Now we're going to do 8i times negative 2 to get negative 16i, and 8i times negative 5i would be negative 40i squared. Now once I distribute this, I know that I squared is negative 1. So negative 40 times negative 1 would be positive 40. So when I add the like terms together, the negative 6 and 40, I get 34. And negative 15i minus 16i would be negative 31i. And that's how I would leave it. Okay? That's how I would leave it. Now, a couple things I want to make sure I note from this, okay, is that make sure that when you do add like terms together, you put the whole number first and then the imaginary number. Okay, we call that standard form. So just a couple things just as you go forward, make sure you have the whole number first with the imaginary to follow. Okay? All right, now in this one, what would you multiply this one by? I want you to yell it throughout your house, just like Dora the Explorer. And you are exactly right. We're going to distribute this by 3 plus 2i, okay? We're going to distribute the top and then distribute the bottom together as well, okay? Very similar to what we had before. Make sure once we get to that point, we divide it up between it as a fraction, just like we did in the other one, okay? Number 8 is another one that can be tricky. What we desire to do here is to take the negatives out of the square root to where we would have I square root of 12 plus I square root of 108, okay? Now, when I divvy out 12, this is very important because we're trying to find what we can get as far as perfect squares go. So we can know that we could take this to 3 and 4, where the square root of 4 would be 2. So this could be simplified to 2i square root of 3 because that does not have a pair. Now with 108, we know that 108 would be like 2 and 54, and 54 is 9 and 6. So the square, or let's keep going just in case. So 3 and 3, and 6 is 2 and 3. So we have 2, 3, 3, 2, 3. So what we can do with that is we can say, what are the pairs? Well, we have a group of 3s and a group of 2s. So we're going to pull 6 to the outside. And what we're going to do is we're going to leave that 3 here on the inside. And remember, we have that I as well. So we have 2i root 3 plus 6i root 3. Since we both have an I and we both have the same root, we can add these together to get 8i square root of 3. And that would be my answer there. And that would be it. Now, again, moving forward, we're just going to keep progressing. The next one, number 10, we could do the same thing. The only difference is now we're going to distribute. So we have 2 minus I square root of 2 and 3 plus I square root of 8. Now, you could distribute, or you could simplify square root of 8, but let's distribute first. So 2 times 3 gives me 6. 2 times I square root of 8 would be 2i, because we multiply outsides together and keep the inside to get there. So we have 2i square root of 8. Now we take the negative I square root of 2 and distribute to get negative 3i square root of 2. And negative I square root of 2 times I squared of 8. We multiply the outside to get negative I squared. Square root of 2 times 8 would be 16. Now this is where we can start simplifying. And so like for instance, the square root of 16 would be 4. Okay. I squared would be negative 1. And we also have a negative on the outside. So this is going to be positive, positive. So this will be positive 4. So we have negative 3i squared of 2 plus 4. And 8 would be 2 times 2 times 2. Or we could take a 2 to the outside to get 4i square root of 2 with the 6 on the outside. Now, once I add this, I can get 10, okay, because 10 and 4 make, or 6 and 4 make 10. And 4i root 2 minus 3i root 2 gives me positive I root 2. And the reason why we can add those together is it has the I as well as the same root. If it didn't have one or the other, I wouldn't be able to do it there, okay? All right, perfect. Now let's do the next one is, let's keep going. The next one talks about maximum and minimums. Now, very similar to what we've done before, if this 4 is positive on the outside, we know that this graph is going to go up, making my vertex a minimum. But if it is negative, it is going to go down, making my vertex a maximum. Now, either way, we're going to solve for what that maximum or minimum is the same way. We have to know whether it is a maximum or a minimum. So just be careful. If it's positive, it's going up, so we're going to have a minimum. And if it's negative, it's going down, and it will have a maximum. Okay? All right, perfect. So in order to do my vertex in either of these problems, let's do 14. We're going to do negative b over 2a. Now, once I do negative b over 2a, b is obviously the 6. So we have negative 6 over 2 times a is negative 3. Okay, so we'll put that in. So what we have is negative 6 divided by negative 6, which when reduced would be positive 1. Now, how do I find what that y is? Well, we can find what the y is by plugging 1 back into our equation for x. So it should be negative 3 times 1 squared plus 6 times 1 minus 4. So 1 squared, because of PEMDAS, we do that first. 1 squared would be 1 times negative 3 would be negative 3. 6 times 1 is 6 and minus 4. So this whole thing, when combined, would be negative 1. So my vertex would be 1, negative 1, and it would be a maximum because right here, this is going to go downward, leaving me the highest point being the vertex. Therefore, we have a maximum at that point, okay? Again, you can see all these answer sheets later as well. Also, quadratic formula I skipped. You could look at that as well on the answer sheet. Miss Allen also was gracious enough to put those on there as well. So I'll post those on the top of Haiku. If you have any questions on that, you can access those at the top of the Haiku page. All right. Now, within end behavior, it's another good one. End behavior has 4 different rules. Now, these rules, sorry about that. I'm going to put them here. These rules are going to be put on the board. But nevertheless, it is important to kind of analyze in moving forward. For instance, we need to know 2 things. Number 1, what is the degree? Is it even or odd? And is the lead coefficient positive or negative? Okay. So we have 2 scenarios where it's even, 2 scenarios where it's odd, 2 scenarios where the lead coefficient is positive, and 2 where it will be negative. Okay. So this is the lead coefficient we're talking about on the bottom side. All right. Lead coefficient. All right. So if it is even, meaning the degree is even, and the lead coefficient is positive, we will rise to the right and rise to the left. Okay. Falcons rise up. All right. If it is even and it's negative, we will fall to the left and also fall to the right. If it is an odd exponent, okay, odd degree, and its positive lead coefficient will rise to the right and fall to the left. If it's odd and negative, we will rise to the left and fall to the right, okay? So those are the 4 different types of graphs we have. So all you need to do is know how do we utilize it. So for instance, if this is it's an even degree with a negative lead coefficient, what we know is if it's even with a negative there, even with a negative, what we know about that is we will fall to the left and fall to the right. We'll put that down. Now look at 16. On 16, we have an odd degree with a negative lead coefficient. So if it's odd degree with a negative lead coefficient, or the number in front, we'll rise to the left and fall to the right. Okay? Excellent. Hopefully that helps you there. So as we keep going forward, what I'm going to do is I'm going to go backwards just a hair and make sure that we understand some of these previous things so that when we do come back, we'll go from there, kind of change things up. This problem right here will be a good one for the test just to make sure we understand it. X to the 4th plus x squared minus 6. In this example, usually we have like x squared plus x minus 6. However, in this one, a little different because with that x to the 4th, we do it the same way. The only difference is that when we end up divvying this out, we'd have x squared and x squared on the inside. Now, just in case, you might want to distribute once we're done to be sure it equals it out, but it would be the same thing. So what 2 things multiply get me to negative 6, but when added get me 1? Well, that would be plus 3 and minus 2. Now, what if I said find the zeros of this? Well, you could say x squared plus 3, set it equal to 0, and x squared minus 2 equal to 0 to be able to solve for what x is. So when I subtract 3 and square root, x would be equal to plus or minus I square root of 3. Okay, because I subtract 3, square root, negative 3 would be the I, the outside, and go from there. Now, if I add 2 here and I square root both sides, this would be plus or minus, x is equal to plus or minus root 2. So those 2 examples, or those 2 values, or really 4 values, would be where it's at. So actually, are these zeros? And the answer would be no, because an imaginary number is not a real solution and would not be able to be a x-intercept or a 0. Okay, so just be careful on that. Note that with the x to the 4th, what you do with that one. Okay, now with this one, very similar to what we did earlier, I think we've done these the last 2 days, is if we have negative 1 as a 0, and we know that, okay, we know that negative 1's a 0, what we can do is next to it, we could put our coefficients. So 1, negative 2, negative 1, 2. 1, -2, -1, and 2. So in this example, we could bring down 1, okay? 1 times -1 is -1. We then add the -2 and -1 together to get -3. We multiply -3 and -1 to get +3. 3 minus 1 is 2. 2 times -1 is -2. And obviously, if I tell you it's a 0, that means that the remainder would have to be 0 within this problem here. So what we have now is x squared minus 3x plus 2. So if we were to factor this, which we can, we could factor this to x minus 2 and x minus 1. What that does is if we set it equal to 0, x would then be equal to 2 and +1. But there's also another one. Remember, -1 was another 0 that was included because that was given in the actual problem, okay? All right. As far as synthetic division goes, very similar. Make sure that in both of these problems, like in here, you miss a x to the third. So what you would do to set this up for synthetic, you'd put a -3 in here because we say what with x, what do we plug in for x to make it equal to 0? That'd be -3. Whereas in this last one, we were given that -1 was a 0, so we do not change the sign there. It's very important. So the coefficients that go in front would be 3, 0, 2, -8, and -4, okay? And we would do the same thing with synthetic as we did in the previous one. I just wanted to make sure we hit on both 22 and 23, okay? All right, let's give a next one here. Let's say that x squared minus 2x plus 1 is going into, and this is different than 25 because I told you I would be, let's say, x to the fourth plus 0x to the third because it didn't have one, minus 2x squared plus 3x minus 4, okay? So let's divide this out. So first thing we want to do is it's the question, what times x squared gets me x to the fourth? What times x squared gets me x to the fourth? And that would be x squared. So we're going to put that there. Now, once I get here, I'm going to distribute all the way out to all three of these and put them down below. So x squared times x squared would be x to the fourth. X squared times -2x would be -2x to the third. X squared times 1 would be x squared. Thank you so much. I appreciate it. I've got it. Everything's good. Thank you. Sorry about that. We changed the signs here. Okay, change the signs to where that's gone. And we're now left with 2x to the third minus 3x squared. Okay, so we've got that there. Now, we've got to bring down one more, that 3x, down below. And so now we ask the same question. What times x squared gets me 2x to the third? You'll see a common pattern. It's just doing that pattern. It can be a little tricky. Well, that would be 2x, right? So we have to put 2x here. So 2x times x squared, we do the same thing, would be 2x to the third. Hint, the first value always cancels. So if you don't, you might want to figure that out, okay? 2x times -2x is -4x, and 2x times 2 is 2, or 2x times 1 is 2x. So then we change the signs because, again, we have to cancel out this first value, leaving us with x, this should be x squared plus x, and bring down that -4, okay? Last but not least, what times x squared gets me x squared? It's plus 1. 1 times x squared, and this, again, we're just going to continue forward. X squared, okay? And this is running out of room here, but I'll kind of put it here. So this is what we had, right? But when we distribute 1 times across, we get x squared minus 2x plus 1, okay? Because it's not allowing me to go any further than this right here. We change the signs, leaving us with 3x minus 5. And that right there would be our remainder, okay? So it really, our answer should be x squared plus 2x plus 1, or remainder of 3x minus 5. Okay, and that would be our answer. That would be it, okay? Hey, I hope this has been helpful so far. We only got a few more left. I've got one up above and then one right here. Remember with this, x-intercepts, plug 0 in for y, okay? That's for x-intercepts. And for y-intercepts, we plug 0 in for x. So this is y-intercepts. This is x-intercepts. 0 in for y is x-intercepts, and 0 in for x is y-intercept, okay? So just be careful on that. The vertex is negative b over 2a, All right, so just be leery of that, negative b over 2a. Domain and range, we should be good on that, but just be careful on this one. Again, I did that one in class, and Miss Allen did it, but I want to make sure we at least talked through it. All right, last but not least, this last one, and then I'll do one more actually once we're there. Let's say that I have a different one than, because I did both 20 and 21 in class. Let's say I had one that said x minus 3 to the 7th, x minus 4 squared, and x to the 3rd. What would be my zeros for this? Now, a lot of these, some of these like 21, you'll have to factor first. And hopefully you know how to do that. But let's say I got to this and this was all that was given. My zeros for this would be 0, 3, and 4, because we set them all equal to 0, right? Remember that. So once I get to that, my question is what's the multiplicity? Well, 0's repeated 3 times, 3's repeated 7 times, and 4's repeated twice. So then it will ask us, what is it doing at each 0? Well, if it has an odd multiplicity, it is going to go through. Odd multiplicity means it goes through. Remember, multiplicity is how many times it repeats. If it's even, it bounces. So anytime it has an even multiplicity, we bounce on that graph or the x-intercept, and then we return, okay? All right, so hopefully this is all getting there, hopefully helping you out. My last one that I wanted to go through is I wanted to come back to, actually I'm just gonna make one up. Let's say we had f of x equals x to the 3rd minus 2x squared plus 7x minus 10. And I said list the by using the rational zero theorem, okay? List the possible roots of this x-intercept or possible zeros. Well, remember we do p over q. And by the way, this is not on the review, but very, very important. Well, p would be 10, where q would be 1, okay? What that means is we've got to find the factors of both 10 and 1. Well, the factors of 1 would be plus or minus 1. And if it was more, we would put that down, okay? So if it was 2, it'd be 1 and 2. What are the factors of 10? Well, we have 1, 10, 2, 5, okay? What that now means is because it's all underneath 1, we just list whatever's on top. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. These are the possible zeros of this polynomial here, okay? Now again, what if I had, let's say this q was a 2, and let's say it was a 2 here, we'd have plus or minus 1 and plus or minus 2. So this would be half of them. Now we would have to put 2 underneath 1, 2 underneath 10, 2 underneath 2, and 2 underneath 5, and list all of those out as well, okay? If they were repeated, such as 2 over 2 is 1, you don't have to rewrite that again. You just leave it, just skip over that one, okay? Now, what if this, if I said find the end behavior, let's bring it all around. This has an odd degree with a positive lead coefficient, so it should rise to the right and fall to the left, okay? So just be careful, and you would write this out. I didn't do it on the last one, but rise right and fall left, okay? Hey, I went through a lot of information there. I apologize. I went through this very quickly. Miss Allen has further podcasts on there that you could access or go through. Thank you so much for showing up tonight. Tomorrow morning, 8 to 9, feel free to come by. I'll have that study session there as well. Have a great day, y'all. Care about you. Have a great one. Bye now.